Hello Year 9. This week's first job is some calculation practice. Okay, I've got two calculation questions. One is about gravitational potential energy, the other one is about kinetic energy. Now, I'm giving you one equation, I'm not going to give you both. You should try and remember both of these equations. Okay, so I want you to pause the video and I want you to try and answer these two questions. Just jot down an answer, back in your book, try and show your workings, and then we'll go through those solutions in the next slide. So pause the video now and spend about maybe 6 or 7 minutes, 3 minutes in each, on these questions. You can use a calculator. You can use a calculator. So pause the video here. Okay, hopefully you've now completed your answers and we can compare them to my work solutions. So, the first one, all we're doing is substituting the numbers in. We're putting the numbers that are in this calculation: 50 kilograms, 6 meters, 9.8 newtons per kilogram. Sometimes it will be 10, most of the time you'll be given the number 10, but this is a more accurate number. We're just putting them into the equation, just timesing them all together. 50 times by 9.8 times by 6.0. And that gives me 2,940 joules with a capital J. If you missed the unit, if you didn't write down J, okay, give yourself a little cross, don't have the units. Okay, that unit will get you a mark. Okay, even if you get the calculation wrong, writing down the unit will get you a mark. Okay, in this question. For the next one, you need to know the equation. Kinetic energy equals half times mass times velocity squared. Don't forget the squared part. And we're just doing a simple thing. We're just substituting the numbers in. We don't need to rearrange for either of these calculations. So we do half times by 2,450 kilograms times by 40 squared gives me 1,960,000 joules. And again, if you don't have the unit, you don't get the mark. You've got to put the units in. So, last week you had some exam questions as your remote learning work. Some brilliant work has been uploaded. Here's a couple of examples. Really like the working here, really clear, writing the equation out, substituting the numbers, rearranging, giving the answer. Okay. If you times your efficiency by 100 to put it into a percent, you have to have the unit of percent. You need to put in that unit. Okay, if you leave it as a decimal, fine. Don't need a unit. There's no decimal for that number. There's no unit for that decimal. But if you times it by 100, you need to put it as 60% efficient. Okay, so put in that percentage there, just like we got here. Percentage, that's fine. 0.6, that's fine. But if you times it by the 100, you need to put in the percentage sign. Okay? But on the whole, some really great uploaded work. Here's a nice example of a Sankey diagram. Good sketch. Okay, that thickness that I've talked about in the last couple of videos is quite consistent. So the 100 going in, 3 thick, 2 thick, 1 thick. Okay, about. Okay, really clear. So good job, Year 9, well done. This week we're looking at something different. We're still looking at energy topic, but I've got a question first. We've got a picture. What on earth is going on in these pictures? Okay, I've got houses. It was from last year, February, March time, and snow had fallen, and we're looking at the roofs. What's happening on the roofs on these different houses? Okay, so I want you to pause the video and I want you to jot down or just think or write them out in the back of your book or say them out loud, something. What do you notice about these pictures? What's happening in these images? And maybe try and link it to our energy topic. Why am I showing you these pictures? Okay, so pause the video here and have a think, and then I'll talk through it. Okay, so for the first thing I spot, some of the roofs have snow, some of the roofs don't have snow. Snow here, no snow here. Snow here, snow here, no snow. Okay, some of these houses definitely had snow on them. As you can see here, there's bits of snow here. You can see this house. This bit of the roof has snow on it. This bit, it looks like it's melted. It looks wet. This house, this roof, hasn't had any snow melt. So what might be causing that? How is it linked to the energy topic? Okay. Now, if in your thoughts, if you're jotting down, you wrote insulation, give yourself a massive pat on the back because you're 100% right. some of these houses have better insulation than others. I'd imagine, because it's cold and it's snowy, they're all going to have their central heating on. Okay, they're all going to be relatively warm inside. And if it's warm inside and you don't have good insulation, your roof will warm up very quickly. And if your roof warms up quickly, you're not just warming up your home, you're warming up the outside. You're wasting that heat. That heat is wasted. It's not going to be efficient. Okay, and it will cause that snow to melt much quicker on these houses. So I would imagine part of the reason, okay, is that some of these houses will not have loft insulation. Okay, there's going to be other reasons, how much sunlight they're getting. Maybe some houses then have their heating turned up higher than others. Maybe some of them haven't gotten up in the morning yet and haven't turned the heating on. Okay, there's going to be other reasons, but a big part of it will be some will have loft insulation, some won't. Okay, now a massive chunk of our energy goes into heating our homes. This is America. It's very similar to here, apart from the fact that most of us don't have air conditioning. Most of our water, most of our electricity when we're in homes goes on heating. Okay, keeping our houses at a comfortable temperature. Okay, some of it's going to be on heating water, having a shower, having washing clothes. Some of it is going to be on cooking, which I'd imagine a lot of this other section would be. And there's going to be lots and lots of energy used. But the majority of it, in most houses, is going to be on central heating. So it's important that we make that as efficient as possible. So this week's remote learning is going to be a research task on some of the ways we can make our homes more efficient. Okay, so here's a picture of a house. I've got loft insulation, cavity wall insulation, draught-proofing, hot water tank jacket, and double glazing. Okay, these 5 methods you need to know about. You need to know these 5 different ways we can make homes more efficient and reduce the energy losses. Okay, so your job this week, I want you to draw a sketch of a house. I want you to label those 5 different energy saving methods, those 5 different ways of insulating our home to reduce that energy transfer that's wasted. And I want you to research what it does, how it works. Okay, make sure, try to include what type of heat transfer it reduces. Does it reduce convection? Does it reduce conduction? Or does it reduce radiation? Or a combination of more than one? Okay, so for instance, loft insulation, when we put insulation up in the attic, up in the loft, okay, that's going to reduce the conduction between the inside of the loft and outside of the house. Okay, the insulation will be a really good insulator, it'll be a poor conductor of heat, and it will reduce the conduction. Okay, similar with cavity walls. But I want you to find out and research these 5 different areas. So sketch picture of the house, label up with the different types, research the different types of insulation, and write a couple of sentences about each. Okay, a great place to start is BBC Bitesize. That will be linked in this video description and the class charts work. There is a second task. Okay, the second task is optional, and it is mostly aimed at anybody who's opted to do triple science next year. Okay, we are going to be doing this required practical in school. Okay, but as it fits into this part of the unit, I thought it would be nice to link it to you. Okay, there's going to be a link in the description that will take you to this website that I'm going to show you now. So when you click on that link, it will take you to this page. Okay, I've maximised it so you can just see the animation. But it's got an experiment where you've got some mass of water that you can control. You've got an initial starting temperature from 10 to 100 degrees. You've got the room temperature that you control from 10 to 30 degrees. You've got how much insulation, this yellow stuff, is around our water container. Okay, and we've got the time at the experiment. So if I start my time at 0, so at the beginning of the experiment, and my initial temperature is 100, I measure 100 on my thermometer. If my initial temperature is only 60, I measure 60. Okay, and the point of this experiment is to look at how temperature changes over time. So what I'd like you to do, if you can, okay, and if you've got time, it's not too stressful, have a look at this simulation and see what kind of graphs you can produce, some kind of cooling curves and maybe even some heating curves. Okay, so what you'll do, if I'm playing around with it, I'd set the mass level quite low. And what you think about why that helps you generate a nice graph here. Think about why we're setting that quite low. And then I'll set my initial temperature maybe at 80 degrees. My room temperature is 30 because my lab's always really hot, especially in the summer. I can start with 10 layers. I can start with no layers of insulation, and I can plot a point. And it plots that point 80 degrees. And I can move on some time. After 1 minute, I can plot another point. After 2 minutes, after 4 minutes, after 7 minutes, after 9 minutes, after 12 minutes, after 14 minutes. And look at the curve. It started out looked like a straight line, but it seems to be a curve. Directly proportional or not directly proportional? Not directly proportional. Okay? As time is increasing, the temperature is dropping. It's not doing so at a constant rate. It is not directly proportional. Okay? And look, what seems to be happening? Where does this temperature seem to be going to? What won't the temperature drop below in this experiment? We've got more points. 32 minutes, 51 minutes, 60 minutes is the maximum. And what's that final temperature? It's at 30 degrees, our room temperature. Okay, so what you can do, you can vary the initial temperature, so you can see how that changes the curve. Think about what's its final temperature going to be. You can change the room temperature. Okay, you could change the number of insulation layers, what might happen with this graph. Okay, you can do all these different things. So just have a play, have a look, okay, and follow some of the instructions that come with it. And if you want to, you can sketch a couple of these cooling graphs or heating graphs, if you go the other way, and just jot down some interesting information you might find out about it. Okay, but your primary goal is to do the research task about the different types of insulation within a house to reduce energy loss within a house. Okay, I hope you're having a fun time at home. Hope you're working well. Take care of yourselves. Take care of your family.